Assalamu alaikum everyone. How are you? So, lecture number 21. This is the AGO, aims, goals, and objective. That what will we do in lecture number 21? As usual, we will go through the brief revision, then we'll focus on the types of chemical reactions. Okay? I told you that if you have any question, you can ask me in the group. All right. So let's start. So this is revision, as I told you. This is revision. We know that in an atom, a normal atom, a neutral atom, the number of electrons and the number of protons are equal. Right? Now, an atom can lose electron or can gain electron. If it loses electron, it will acquire a positive charge and we call it a cation. If it gets an electron, it will acquire a negative charge and we call it anion. It's not necessary that an atom always lose one electron. It may lose 1, 2, 3, 5, as the case may be, or can gain only one electron. These cations and anions are collectively called ions, or people call it ions. Okay? So when you see something, and species carrying a plus or minus charge, you will say it's not a neutral atom. It's an anion or cation, as the case may be. So this was different cations and anions. Okay, what is the topic today? Types of chemical reactions. In the last 10 minutes, I explained this topic very briefly. Okay, so there are all the different kinds of reactions can be divided just into 5 categories according to our textbook. All right. So we started yesterday with addition reaction. Its another name is combination reaction, or synthesis reaction, or formation reaction. You can see this one on number 3. Then it was there was another one, decomposition reaction. Then single displacement or single replacement reaction, double displacement reaction, and finally the combustion reaction. You can see on the right bottom that addition reaction means 2 or more than 2 atoms combine to form a single molecule. The reverse of it is decomposition. The bigger molecule will be decomposing, will be aparting into smaller atoms or compounds. Then in the single displacement reaction, one of the atom displaces another one. Obviously, the stronger one will displace the weaker one. It happens everywhere. In chemistry also it happens. Then the double displacement reaction, we'll see. And finally, the combustion reactions. Combustion reaction means reaction with oxygen. It could be atmospheric oxygen or any other. All right, so we'll go through these reactions one after the other. All right. Okay. This we have done on the board. Combination reaction. The topic is a little bit typical. That is why I'm trying to explain it by different ways, so that you will be able to understand it. Okay, not by one way, then by the other way. All right. So the first reaction is, most of you know, I told that if you think that you are intelligent enough, then go through the your book on pages number 26, and you will find these topics there. So if you have gone through, you will be able to understand it very easily. Or maybe you already know it. That is so simple. Anyway, so what do you mean by synthesis reaction? In which two or more than two atoms can combine together to form a bigger compound. Like carbon and oxygen. Carbon, what is the symbol of carbon? C. What is O? Oxygen. Oxygen always occur in molecular form. Means as I'm inhaling oxygen, then it is not atomic oxygen. It is the molecular form of oxygen. And we have studied what do you mean by a word molecule? When two or more than two atoms combine together, they form a molecule. So oxygen occurs in atmosphere in molecular form. That is why we write O2. Whereas carbon occurs in atomic form. That's why we write only C. So C plus O2, it will form CO2. How? These two will react together. Slowly and gradually, they will combine and they will form what? They will form carbon dioxide. So this is called a synthesis reaction, an addition reaction, a combination reaction, a formation reaction, whatever you say. The meaning is same. All right? So generally, what can we write? We can say that A and B can combine together to form AB. Is it clear? Now see the examples. The first example you can see on the screen. Today, the board work is very less. In the first example that you can see, nitrogen. Nitrogen, where can we find nitrogen? Yes, our atmosphere contains the biggest quantity of a gas, that is nitrogen, around 77%. So our atmosphere contains 77% nitrogen. This nitrogen is really inactive. That is why it is used in different areas. Like you can find nitrogen in a packet of chips, potato chips. Okay, it contains nitrogen. That is why it is so inflated. All right. So nitrogen, when made to react with hydrogen, symbol of hydrogen is H. They will form a compound that we call it ammonia. Ammonia is a very common compound in chemistry. Its formula is NH3. This is ammonia. Okay. It is prepared by a process, means who gave this process to react nitrogen and hydrogen to produce ammonia. Just for your info, it was given by Mr. Haber. Haber's process. It is called Haber's process. And the next one, hydrogen and oxygen can combine together in special conditions to forming what? Water. So nitrogen, hydrogen forming ammonia, hydrogen and oxygen forming, producing. Okay, so these are synthesis reaction. Similarly, you can see that calcium oxide. If you know those chemicals, the list of chemicals that I told you to go through, then you will be able to understand these formulas very easily. Calcium oxide, when reacts with carbon dioxide, it forms calcium carbonate. Okay? Now, an IQ, chem IQ. I don't want answer here. Answer me individually. What is the common name of CaO? What is the common name of calcium oxide? I repeat, what is the common name of calcium oxide and calcium carbonate? I repeat, it's not an assignment. It's just to enhance your chem IQ level. I want to know the common names of these two chemicals, calcium oxide, CaO, and calcium carbonate, CaCO3. All right? Okay. So again, you can see the combination reaction is occurring here. Two substances can combine together to form a bigger compound. See another. Calcium oxide, when put in water, it will form calcium hydroxide. Calcium hydroxide. Again, I would like to know that what is the common name of calcium hydroxide? What is the common name of calcium hydroxide? All right? Calcium oxide, calcium carbonate, and calcium hydroxide. Right? Why it is called hydroxide? Because you know from the list that OH stands for hydroxide. So that is why its name is calcium hydroxide. Sodium and chlorine can combine to form sodium chloride, the salt. Potassium and chlorine can combine together to form what? Potassium chloride. So all of these are synthesis reactions. You can choose any 2 or 3 to for your notes. Okay. Among from these two are there in the book. The ones which I ticked, these are the 2 examples which are there in our book. So synthesis reaction is over. Okay. Now the next reaction is decomposition reaction. Today's class is comparatively easier. Decomposition, breaking up a bigger molecule into a smaller. Okay. The reverse of the first one. In synthesis reaction, 2 or more than 2 substances combine to form a bigger one. Here we have a bigger compound, and by applying some technique, we can convert them into smaller ones. This is called decomposition reaction. So decomposition is done by using some force, by using some energy. And what is that energy? It could be heat energy, it could be light energy, it could be electrical energy. You will be needing energy to break. You will have to put effort for the breakup. Okay? These two, if you want to change their bonding, you should apply some force. So what is written on the screen? A reaction where a more complex molecule splits down, breaks down into 2 or more simpler products. As you can see on the screen, A and B. AB is a compound, and after the application of some force, some technique, it is converting into A and B. All right, let's see the examples. A compound HGO, then it can be decomposed. HG, what is HG? Good. Hg is the symbol of mercury. But in mercury, there is no H, there is no G. Why? Because the symbol of mercury, Hg, is obtained from its original name, hydrogyrum. Okay? First lecture. Anyway, so you can see Hg and O, they have been separated. Another example, you can see water. Might be you have heard that someone has invented a car which runs on water. So what was that man or all the other men dealing with? They all focus on the electrolysis of water. Electrolysis means passing electricity through a solution. When you pass electricity, the component of the solution break. The components of the solution breaks. For example, if you pass electricity with some acid base, then it will decompose into hydrogen and oxygen, decompose. So it's a decomposition reaction. It's a decomposition reaction. And what do we, which force we are, which technique we are using here? With the help of electricity. With the by passing electricity, water is decomposing into hydrogen and oxygen. Okay? So decomposition means to break up. Anyway, I know you will feel difficulty in it. Single displacement reaction. Can you understand the single displacement with the help of diagram? Triangle. We are supposing here that triangle is more powerful than square. Then what will happen? Triangle will come and kick off the square. Square will go away and triangle will make a new relationship with circle. This is called single displacement reaction. Why? Because triangle is replacing square over here. So what is the definition written? You can see on the screen. In a single displacement reaction, one element displaces another element. And obviously I told you that it's always a stronger atom, a stronger element will displace a weaker element. Okay? In this type of reaction, an element and a compound react and form a different element of one. Okay? Now see the examples. Anyone of you remember the example that I gave you yesterday? Zinc reacts with HCl. What is the symbol of zinc? Zn. What is HCl? Hydrochloric acid. So zinc is stronger than hydrogen. So zinc will come and replace hydrogen. See, in the second reaction, zinc is displacing hydrogen, zinc chloride and hydrogen. Same is true in the first reaction. The iron being more powerful than copper, so it will displace copper and it will occupy its position. That's why the thing formed, the compound formed would be FeSO4. What do you call it? Fe means iron, iron sulfate, or its common name is ferrous sulfate. Its another name is ferrous sulfate. So in these two examples, single displacement reaction occurs. Like in a football match, if someone is injured, then what happens? There are 11 players on the ground, they can only replace. So the injured one will come out, okay, and the other one will go in, displacement reaction. Same will happen here. So these two lines on the screen, you are not going to learn or memorize them. This is just for your info, that which one is stronger than which one. So potassium is stronger than sodium, sodium is stronger than calcium, then magnesium, and then. This is called the activity series. This is showing that which one is stronger and which one is the weakest. if you have any interest in it, just Google activity series in chemistry. You will see the answer. That which element is stronger than the other one. So, copper sulfate, a solution. If you put a nail of iron in it, we have just seen that iron is more powerful than copper. What is the solution? What is the color of the solution on the left side? Blue. Copper sulfate, the solution of copper sulfate is blue. Why do you have seen in grade 8? When you put an iron nail in it, what will happen? Iron will displace copper and forms iron sulfate or ferrous sulfate. That's why the color changes from blue to green. So the same concept, displacement, displacement, displacement. Now I hope that you have understood. Zinc will displace, zinc will kick off rather copper. Okay? Okay, okay, okay. All of these reactions, zinc is replacing Sc hydrogen, potassium replacing sodium, copper chloride. You should be able to read the chemicals over here. If you want, if you are unable to read, it means you are weaker, you have not studied the previous day's assignment or work that I gave you. Magnesium replacing chlorine, replacing bromine, and these two are there in the book. All right, so synthesis, decomposition, single displacement reaction. Now the double displacement reaction. So simple, this one. The two chemicals will exchange their partners. Like in the first one, Na will replace lithium, Li. Na will become the partner of F, and Li will become the partner of Cl. Means the displacement is occurring at two places. That is why it is called double displacement reaction. See, the partner of calcium is sulfur and the partner of magnesium is oxygen. Then after reaction, there is an exchange. Calcium has gone with oxygen and magnesium will become the partner, has become the partner of sulfur. This is the most convenient way. If we have a reaction A, B and CD, then it will convert into AD and CD. Okay? Simple. Now the last reaction is combustion reaction. So what do you mean by combustion reaction? Reaction with oxygen, I told you earlier. Reaction with oxygen. If a thing is reacting, if a substance is reacting with oxygen, we call it what? It's a combustion reaction is going on. And we know that to burn, we need oxygen. Okay? So either you burn coal in an open atmosphere, or you burn sui gas in your kitchen, or CNG in the vehicle, or petrol in the cars. Combustion reaction. Might be you have heard there's a combustion chamber in the engine. So fuel plus oxygen, this is called combustion reaction. So when fuel reacts with oxygen, two chemicals definitely formed, water and carbon dioxide, along with the release of heat energy, that heat energy, nitro. Okay, all right. If you are using nitro in a vehicle, that is something different. Even then, it's a combustion reaction. Even then, it's a combustion reaction. So, combustion reaction occurs when oxygen reacts with another substance and produces large amount of heat and light. Example, burning of coal, burning of octane. Octane is high octane petrol. Methane or methane, whatever you say. Methane is the major part, I told you, of R3 gas. So these are the 5 reactions that we have covered today. Carbon plus oxygen, carbon dioxide, synthesis reaction, decomposition reaction, single displacement reaction, double displacement reaction, and combustion reaction. Let me give you an example of double displacement reaction. Suppose we have AgNO3 and we made to react with sodium chloride, silver nitrate. Then these two will exchange their positions. It will come to its, then what will it become? Na will come over here, it will become NaNO3, sodium nitrate, plus silver will come over here, AgCl. It's a double displacement reaction. Another example, sodium hydroxide plus HCl. Then this will come over here, this will come over here. Sodium chloride plus HOH. This HOH is called water. Okay? So you can see other examples. What is the homework? Not at all. Just go through the topic that we have just discussed by yourself, just for you. And what will the upcoming task that I would ask on Monday, that I will take a short test of all the problems, not a theory part of chapter number 2, like find the molar masses, like find the number of moles, like find the number of molecules by using Avogadro number, or I can give you some formulas. Okay, it is just to prepare, just to update, just to revise the previous work. Clear? No homework. What will we do tomorrow, inshallah? Balancing of chemical reactions or chemical equations rather. Thank you so much.